Hello viewers, so we have this question that says a 0.15 molar acetic acid solution has a pH of 3.6. Find Ka for the acid. So in this case, we're finding the Ka for the acid. So the first step is to write the dissociation for this acid. So let's do that. We have CH₃COOH. This is acetic acid. So when you put it in water, on the other side, we're going to produce the hydronium ions like that, and the conjugate base. So I've been just shown water, but this is what we're going to get when you put it in water. We're going to produce the hydronium ions, this here, and the conjugate base for that acid. So after writing its dissociation equation, we're going to write an ice table. So let's put our ice table there. On our ice table, from the question we're given to say we have an initial concentration of 0.15 for the acid. So we're putting that. Then we have nothing here. We also have nothing on the other part. Since we have nothing on the right side, the left side is going to reduce by a certain amount that we are calling x. So it will reduce by minus x. Then we'll have plus x here, and we have plus x there. And then on this part, we're going to have 0.15 minus x. Then we're going to have x there, and we have x here. So that's our ice table. After doing this, the next step is to write our Ka expression. So Ka expression will be equal to the concentration of the products, like that, multiplied by the concentration of another product, yes. So we have that, divided by the concentration of the acid here. So the Ka expression is basically the ratio between the concentration of the products to that of the reactants. Well, so let's proceed. This implies to say our Ka, replacing with the values we have at equilibrium. For the top part, we only have x, that is multiplying by another x concentration. Then down here we have 0.15, that is subtracting by x. And in this case, our Ka will be equal to, now, remember we are given the value of pH. pH is given to be 3.6. Now, that pH value can help us find something. That something we're talking about is the value of X, which is the hydronium ions. This value of X here, which is also the hydronium ion concentration. So we can find it using the value of pH that we are given. So let's do that. From the formula that says pH is equal to negative log of the hydronium ion concentration, like that. This hydronium ion concentration, making it the subject, will be equal to, so this will be equal to 10 to the power of minus pH. If you remember your logs, you bear with me there to say that's what we are going to have. So the concentration of the hydronium will be equal to 10 to the power of minus pH. So we have our pH. What we have to do is, this is going to be equal to 10 to the power of minus 3.6. 3.6 there. And when we do that, according to my calculator here, what I'm getting is 2. This is equal to 2.51 times 10 to the power of minus 4 molar concentration. So this is the value that we are getting for the hydronium ion concentration, which is also the value of x. So it implies to say, now coming back to our Ka here, on top we're going to have x squared, which is basically 2.51 times 10 to the power of minus 4 squared, like that. Then this will divide by, down here we have 0.15 minus the x value is 2.51 times 10 to minus 4. So all we have to do there is do mathematics, and when we do our mathematics, we're going to find our Ka value to be equal to 4.21 times 10 to the power of minus 7. So this is our Ka value for this acid.